Hey everybody, we're gonna do another problem. We're gonna do part two of section 3.6. That's find the area between two curves, and that is a lovely, wonderful thing to do. And we're gonna do it right now. So here we go. Let me switch cameras, and we're gonna start with a nice little problem here. Here you go. Find the area bounded by the curve y equals 2 minus x squared and y equals negative x. So here we go. Here we go. First thing I'm going to do is I'm going to draw the graph. This is a pretty straightforward graph to draw. That's just an upside down parabola, and that's just a diagonal line. And it goes to the origin and has a slope of -1. So let's see. I'm going to draw the parabola first, I guess. The parabola is the y-intercept is 2, and then it's just an upside down parabola. So I'm going to go up to 2. I'm going to draw my parabola that way, and go down and draw my parabola that way. And yeah, it's going to go. And my so this is y equals 2 minus x squared. Now for my other one, my next trick, I have a line through the origin, and it's going to basically just go on a diagonal, kind of like that. And it's going to hit right there. And what I want is I just want this area that's in between these two curves. By the way, even though the bottom curve is a straight line, but we still call it a curve. And that's very simple. I'm just going to have to take an integral, just the integral, the top integral, the purple top integral, minus the blue bottom integral. The only thing is, the only little trick is, not trick, but the only thing we have to deal with right now is a little bit of algebra, because I'm going to take the integral from whatever that x value is to right there. I'm going to take the integral from this x value to that x value, but I don't know what the x values are. It doesn't tell us. So what we're going to have to do is do a little bit of algebra to figure it out. Y equals -x. So what I'm going to have to do is, well, both of these are equal to y, so I'm going to set them equal to each other. I have 2 minus x squared equals -x. I'm going to add x squared to each side, subtract 2 from each side. And just to write this a little bit nicer, this is x squared minus x plus 2 equals 0. And let's move this a little closer, okay? And this factors pretty easily. This factors into x, let's see, plus 1, x minus 2, because plus 1 minus 2, oh, sure, that should be a minus 2 right there. I have it right here. So x squared minus x minus 2, I have the minus 2 right there. That is x plus 1, x minus 2. So this gives me x equals -1, x equals +2. Obviously, that's the -1, and that's the +2. So I'm looking at here, I'm looking at the integral from -1 to +2 of the purple parabola, which is 2 minus x squared, minus the blue line, which is -x, and all that is inside my integral. I'll put it in a big case right there. And this is equal to the integral from -1 to 2 of, let's see, that's going to be -x squared, +2, +x. So that is, oops, something, you all still there? Let's make sure everyone's still. 2 plus x minus x squared. That 2 is positive. That minus a negative becomes positive, and minus x squared, sticking at the end, dx. And this is a very, very, easy integral to integrate. This is just equal to the 2 becomes a 2x. The x becomes an x squared over 2. The x squared becomes a x cubed over 3. And I'm evaluating this all between -1, and 2. In other words, so this just equals, so first I'm going to plug in 2 for x and crunch that out. I'm going to plug in -1 for x, crunch it out. I'm going to subtract the two things. So this is 2 times 2, which is 4, plus 2 squared divided by 2, which is, 4 halves. And this is minus 8/3. And I'm subtracting 2 times -1, which is -2, -1 squared over 2, which is positive 1/2, and -1 cubed, which is -1 over 3, but it's -1/3 minus -1/3, so it's plus 1/3. And well, a lot of negatives there. Um, and there we go. And that is equal to, let's see, let's just crunch this out. This is equal to, then we'll just crunch it over here. This is equal to, let's see, 4 plus 2 minus 8/3 plus 2, because it's a double negative, minus a half, and then minus a third. Oh, the third is going to be nice. So this is going to equal, let's see, 4 plus 2 plus 2, that's 8. Let's see, the 4, the 2, and the 2 becomes 8. The minus 8/3 and the minus 1/3 becomes minus 9/3, and of course 9/3 is just equal to 3. And then the last thing I have is minus 1/2. So this equals 5 minus 1/2, which equals 4.5. So the area between the curve is 4.5 square units. I never specified the units, but it's 4.5. Let me just write that in, square units. Or I'll say, yeah, square units. Whatever the particular unit would be. And let me write that neater so you can actually read it. 4.5. All right, nice and big. 4.5 square units. And that is the answer. That is how we do that. Okay, well done, everybody. I want to do one more. And this actually, I want to do one now, which actually is actually in the textbook. So let me just show you this problem. I have it actually in I have it, I have it, okay, let's just open this up. Scroll down this text a little bit. So here's the problem. Two objects start from the same location and travel along the same path with velocities VA, meaning velocity of object A, is equal to t plus 3, and VB, velocity of object B, is t squared minus 4t plus 3. And these are expressed as functions of time. T is time, and it's in seconds. Or in this case, in the velocity is meters per second. So object A has a velocity of t plus 3. We see that right here. And object B has a velocity of t squared minus 4t plus 3. So the first thing I want to do is draw a graph. Oops. And here we have a graph. So y equals t plus 3. That's just very simple straight line. The y-intercept is 3, and the slope is positive 1, so it just goes like that. And this here is a very simple parabola. It's easy to draw. Again, the y-intercept is 3 because of that 3 right there. and it's a by the way, if you would factor this, it would be t minus 1, t minus 3. That's why those are my x-intercepts. And it's all pretty straightforward graph. Um, the vertex is x equals 2 because negative b over 2a, that formula, and meaning meaning it would be positive 4 over 2, which is x equals 2. And very nice graph. Now, where's the calculus coming? Well, we know, let's just look here. We know that the derivative of distance is velocity. Oh, in fancy talk, we say derivative of position, but in this case, we're going to say which is distance along the path. And that makes sense because velocity means the rate of that the distance changes, the rate that my position or the rate that my position changes. I'm in a certain position, my position changes as I move, and the rate at which it changes is the velocity. So the derivative of position is velocity. That means that the antiderivative of velocity is position or distance. So what I'm going to do here is take the antiderivative, which of course we know is the integral, but I want to compare it. Uh, the I want to find the difference between the top curve, the red curve, and the blue curve. Again, I know it's a straight line, and I'm calling a straight line a curve, but that's what we do. Any graphic, we call it a curve. So the integral between these two curves is the antiderivative, expressed in definite terms. And that area, this yellow area, actually winds up being the difference in distance, which is pretty phenomenal. So this is a very awesome way to use calculus to solve a problem involving distance. Anyways, let's just solve it. So what I'm going to do is just do the integral. Now, I know that we're going from 0 to 3. Does it say that in the problem, or we just yeah? We're starting, and now we're going after 3 seconds. Yeah, so we're going from 0 to 3. Plus, that's with a that's 0 to 3, and so that's what I want. So I'm gonna do. Let me just write this down. I'm gonna switch cameras now, and I'm gonna go to. Oh, 1 second, everybody. Hmm. I just realized something. I didn't have my screen shared when I just showed you those pictures. So let me just sort of repeat quickly what I said before this time with the screen, so you could see what it's all saying. Okay, because I was talking about the yellow this and the red that, and you probably had no idea what I was talking about. I'm very sorry about that. Let me just go back up to the original problem. All right, so two objects start from the same location and travel along the same path with velocities. Velocity A is t plus 3. Velocity B is t squared minus 4t plus 3. These are written as a function of time, and the velocity is meters per second. How far ahead is object A, after 3 seconds? So object A has a velocity t plus 3. Object B has a velocity t squared minus 4t plus 3. So we draw the graph, oops, right there, and we want to find this, as I explained with words before, we want to find the area between the two graphs, because again, the velocity is the derivative of position. So position or distance is the antiderivative of velocity. So if we take this definite integral, the area between these two curves winds up being the difference in distance. And that's pretty cool and awesome. And so again, it's going to be a straightforward integral. I'm going to integrate from 0 to 3 of this red line minus that blue parabola. Only because because the red line is on top, the blue parabola is on the bottom. So I said all this a couple of minutes ago, but I just wanted to actually show you the pictures and share my screen. So now I'm going to go. Now I'm going to stop sharing my screen, and I'm going to go to we're going to go to the actual paper, pencil, and work these out. So I'm looking here at the integral from 0 to 3 of t plus 3, because that was a red line on top, minus t squared minus 4t plus 3. That was the parabola on the bottom. And I just want to first sort of, combine like terms, condense this a little bit, make it a little bit smaller and so forth. So this is equal to, let's see, we have t minus 4t, that's 5t. The 3's cancel. We have a plus 3 and a minus 3, minus 3. And I have minus t squared. So this is going to be t minus, okay, so it's going to be 5t. And that's my integral. This is quite a simple integral to integrate. This is just the derivative of t is 5t is t squared over 2. So this is 5t squared over 2. The derivative of t squared is t to the third over 3. I mean, antiderivative, I'm sorry. And I'm going from 0 to 3. And I love having zeros because it makes the work a lot easier. This is now going to equal 5 times 3 squared over 2 minus 3 to the third over 3, and then minus 0 minus 0. And that just equals, let's see, this is 5 times 9 over 2. So this is 45 over 2 minus 27 over 3, which is minus 9. And this just equals 45 over 2 minus 18 over 2, because 9 is equal to 18 over 2. And that is, let's see, 45, that's 27 over 2, which is 13.5. But 13 point, is it just, but 13.5 what? Is it just plain 13.5 or 13.5 chihuahuas, or what is it? Well, let's remember, we're talking about, we wanted to figure out that we said that the integral was going to want of the velocity of these velocity curves, the area between the velocity curves was going to be the distance, the difference in the distance. So we're talking distance here, and the original problem was in meters per second. So this is going to be 13.5 meters, and that is that. So I hope you enjoyed part 2 of our video. We're going to continue with part 3, and but for now, ciao.